So hi everyone and welcome to this video on our discussion on the price leadership models in oligopoly. In particular, we're going to be discussing a particular type of price leadership model, which is the low-cost price leadership model. So let me give first a bit of a brief overview of price leadership models. And it's essentially when one firm will set the price, right? And the other firms will follow it because the other firms believe that it's advantageous to them, or because they prefer to avoid the uncertainty about their competitors' reaction, even if this implies that departure from their own sort of profit maximizing target. So follower firms are willing to swallow the potential loss of not being able to maximize based on their typical profit maximizing position and just adopt the leader's price. And what we see in the data is that more widespread these sort of leadership models are more widespread than cartels, since it allows the members to a lot of freedom regarding their product and selling activities. So the low cost price leadership is the simpler of the two models, and assuming that we have a market in an oligopolistic setting wherein firms have unequal costs, right? Then the firm with the lowest cost, right? The firm with the lowest cost will charge a lower price. And what happens is this price, okay, under this model, will be followed by the higher cost firms, right? Those firms with a cost higher than the lowest cost firms. And what happens is these follower firms do not maximize their profits at that price, right? So they will have to settle for a suboptimal optimization procedure. Now, why will follower firms settle for this? Why can't they maximize at their own sort of price, at their own sort of combination? Well, the follower firms want to avoid a price war at all costs. Okay, they want to avoid that. And in essence, these follower firms prefer to follow the leader, sacrificing some of their profits in order to avoid the price war. And what the price war could do is that it could eliminate their profits if the price falls below their long run average costs, right? So in that uncertainty, they're just willing to go at a suboptimal allocation to avoid the price war completely. Now, there is a caveat to that, in that although the model stresses the fact that the leader sets the price and the followers adopt it, it is clear that the firm must also enter into some sort of share of the market agreement. Whether that agreement is formal or informal, they must enter into something like that. Otherwise, the follower firms could just adopt the price of the leader but produce a lower quantity than the level required to maintain the price in the market. And what will happen is it will also push the leader to a non-profit maximizing position. So it goes on the reverse side as well. Because if there's no formal agreement, then they could just follower firms may produce a very suboptimal amount, not akin to the profit maximizing position, and drive the price into levels wherein it is suboptimal for everyone. So let's get a better picture of this. So let's assume that there are only two firms in the market, and we're gonna define the market share of a firm as KI. So a particular firm, KI, and the market share is just the output that that firm produces, which is QI, small qi, over the total output, which is Q, right? And when we're in a two good case, that's just QI, a two firm case, that's just QI over Q1 plus Q2, right? For all I being equal to 1 and 2. Now, clearly, since there are only two firms in the market, then the total share would be, if I add K1, the market share of firm 1, plus K2, which is the market share of firm 2, that's just equal to 1, right? Because they produce everything. And this suggests that K2, to get the market share of firm 2, that's just 1 minus K1, or the market share of firm 1. And, right, it should also follow that K1 is just 1 minus K2, right? So I hope you can get that simple logic. Now, In this way, in this manner, we can derive actually the output of each firm given as follows. So if you recall, okay, we can actually do this sort of derivation. Q1 is essentially the market share of firm 1 times the total output, right? So the market share is some number between 0 and 1, right? And the total output is just Q1 plus Q2, right? So if we solve for if we can solve for it, so we can get Q1 equal to Q1 K1 plus Q2 K1, right? And we can isolate this as just Q1 minus Q1 K1 plus Q2 K1. I'm sorry, equal to Q2 K1. Okay. And we can simplify this. So this is Q1, 1 minus K1 equal to Q2 K1. Then if we isolate it with respect to Q1, we get Q1 equal to, so that's K1 times Q2 all over 1 minus K1, right? So this is the output of firm 1. And similarly, we can get the output for firm 2, which is just the symmetric of symmetric to that function, which is K2 Q1 over 1 minus K2, right? So this is the output of firm 2, right? So these are the outputs just based on shares, and we know that this is true under a low-cost price leadership model. So let's delve into this more. Okay, so assume that there are only two firms which are producing identical products in a market with a given demand curve. And that demand function, that demand curve, is a function of the total output. Okay, that's a function of the total output. And each firm has a cost function. So that's for firm 1, and this is for firm 2. So suppose that C1 is less than C2 for all for the production wherein Q1 and Q2 is the same. For example, suppose firm 1, I ask firm 1 and firm 2 to produce 5 units of the same good each. Then I compare their cost and I find that the cost of producing those 5 units in firm 1 is less than firm 2. Then I can say that the cost of firm 1 is less than the cost of firm 2, which means that the price leader is firm 1 since it can produce the same output level as firm 2, which is in that example both 5, at a lower cost. So what will happen is the leader will set its price so as to maximize its profit on the assumption that the other firms will be followers and will react to their reaction functions, adjusting their output whenever the leader changes its output, so that the shares, okay, the market shares will remain at their agreed constant levels. So we'll get to know this with the example later on. So suppose that firm 1 assumes that firm 2 will produce an equal amount of output. Okay, so say they had an agreement and they'll split the market evenly. In this case, the relevant demand function for firm 1 is just this. So the inverse market demand function is this one. It's a function of Q. And we know that Q is just Q1 plus Q2. And what this ends up being is that since Q1 is equal to Q2, then this is just P as a function of Q1 plus, since Q2 is just equal to Q1, that's just Q1, wherein we get that the demand is just some function of Q1, right? The demand can be just some function of firm 1's output. Now, we form first the low-cost price leaders problem. And since it's a firm, of course, it's a profit maximization problem. So it's going to try to maximize Q1, right? Maximize profit rather, wherein its choice variable is it can choose to produce Q1, but it needs to meet the share agreement that Q1 is equal to Q2, right? Because they decide to split the market in half evenly. So this is just R1 minus C1 is equal to P times Q1 minus C1, right? Minus its cost. And that's just equal to P as a function of Q1 times Q1 minus C1 Q1, right? Then the first order conditions for that, if I derive the profit function with respect to output Q1, that will be equal to 0. Then to check that it's a maximum profit, the second order condition should be negative, right? As usual. So same conditions as before. And we can show that this FOC, if we solve for this one, will lead us to this condition that MR1 is equal to MC1, where if you recall, MR1 is your typical marginal revenue function, which is the derivative of revenue with respect to Q1. And that's just equal to your demand function plus the derivative of the demand function with respect to Q1 times Q1 via chain rule. And we also have our marginal cost function, which is just dC1 over dQ1, right? So using this FOC, we can solve for the leader's optimal output, right, which is Q1. And what ends up happening is that optimal output, okay, what we do is we can use that optimal output to determine the price, right, of the firm, which is just this one. So plugging it back in. And what will happen is the follower firms will adopt the same price and will produce an equal amount of output based on the market share agreement. So since we assume that they will produce the same amount, then they'll split the market evenly. So I think we can get it better when we go to an example. So suppose that the market only has two firms, both of them producing an identical good. Then both of them face an inverse demand function being equal to P is equal to 100 minus 0.025 Q. And each of the firm's cost function, for firm 1, it's C1, that's 10 Q1. Then C2 is 20 Q2. Okay, and suppose that the two firms agree to share the market equally. So they share the market equally. So let's answer the next few questions. So the first question asks, which firm is likely to be the low-cost price leader? And this should be very simple. So clearly, for all Q1 equal to Q2, since they share it equally, equal to Q, then C1 equal to 10 Q1 is certainly less than 20 Q2, which is equal to C2, right? Because that's 10 times an output, which is definitely less than 20 times an output, assuming both of them are equal. And we can conclude that, of course, C1 will be less than C2. Therefore, the low-cost price leader is definitely firm 1. So quite an easy number. So the next question is, we need to find the low-cost price leader's relevant demand curve. So what we need to do to solve that is to first formalize the market share agreement. So the market share agreement states that the two firms will share the market equally. And this just means that K1 is equal to 1/2 and K2 is equal to 1/2, right? So they share it equally. So of course, naturally, this subscribe to the property that K1 plus K2 is equal to 1. So that's 1/2 plus 1/2. That is indeed equal to 1, right? So because they share the market equally, but we know that since firm 1 has the lower cost, then firm 1 is the price leader. And what will happen is firm 2 acts as the follower and produces, okay, it will produce the output, okay, according to the agreed upon market shares. So if you recall, right, you can get Q2 is just equal to K2 over K1. So how did we get this? So if we plugged it into the form we derived earlier in the very first slide, we can get this expression, right? And all we need to do is we need to just plug in, okay, our given. So if we do that, that's Q2 equal to K2, that's 1/2, okay? And then K1, that's also 1/2, and then Q1, right? And that would mean, so we're just going to cancel it out, that Q2 is equal to Q1. Okay, therefore, the relevant demand curve for firm 1 is its residual demand, i.e., okay, so this is the demand curve, the market demand rather. This is the the market demand. So this is the market demand for which, okay, Q2 is equal to Q1. So how do we get that? So if you recall our demand function, that's 100 minus 0.025 Q. So we're just going to plug it in. So that's 100 minus 0.025. That's Q1 plus Q2. But again, we know that Q2 is equal to Q1, right? That's this condition here. Then this should be equal to 100 minus 0.025 Q1 plus Q1, which just means that P is equal to 100 minus 0.05 Q1. And this is the low-cost price leader's relevant demand curve, right? So that's that. Then letter C states and asks, how much will the leader produce and at what price will it sell the output? Well, as we said, firm 1, as the leader, will choose its output that maximizes profit given that firm 2 produces Q1 units, again, because they share the market equally. I'm sorry, Q2 is equal to Q1 as we proved earlier here, right? So this was our proof earlier. And according to their market share agreement, which is implied by firm 1's residual demand curve. So we're going to use the, since we're now asked what the leader will produce and sell the product for, we're going to use its profit maximizing criterion, which is just MR1 is equal to MC1, right? So this is the leader's FOC. And to do that, okay, we need R1. So R1 is just P times Q1. So this is just equal to 100 minus 0.05 Q1 times Q1, and we're gonna get 100 Q1 minus 0.05 Q1 squared. Then if we get marginal revenue, this is just the derivative of revenue with respect to Q1. This is just 100 minus 0.1 Q1, right? 0.1 Q1. Then our cost function is easier to solve. Marginal cost is easier to solve for. C1 is 10 Q1. If you get marginal cost, that's just the derivative of C1 with respect to Q1. So that's just 10. Then equating the two, MR1 equal to MC1, that's just 100 minus 0.1 Q1 equal to 10. Then we solve for this. So this is 0.1 Q1 equal to 90. Divide both sides by 0.1. We get Q1, or the output of firm 1, being equal to 900. Okay, so that's our answer. And what we do to get the price, as we inferred in the last slide, we just plug it into the demand function. So this is 100 minus 0.05 times 900. So this is 100 minus 45. We get a price equal to 55. So the leader firm will produce 900 units and will charge 55 for each unit. So the last question is, how much will the follower firm sell and what price will it charge to sell its output? Well, as follower, firm 2 sells according to the market share agreement. So the market share agreement, okay, I'm sorry. The market share agreement, okay, share agreement, right? That's just 1/2, 1/2. So they split evenly. So if Q1 is 900, right? If the Q1 is 900, then of course, firm 2 should also be 900. So Q2 is equal to 900, right? And since it follows the price of the leader firm, then P is also equal to 55. So that's our example for low-cost price leadership. And I hope you understand the logic and the intuition of how the follower firm will just simply adopt the price of the leader firm, and it will it will produce the quantity based on the market share agreement that it set so as to prevent a price war. And we'll show in the next video, when we get to the dominant price leadership model, the key differences between these models and how these models end up comparing to your typical Cournot, Stackelberg, and Bertrand. So thank you for your attention in this relatively long video, and I'll see you in our next video.